Find all real roots of the polynomial 5x cubed plus 8x squared plus 6x minus 4. In this problem, I'm not going to only tell you about the rubric and how to do the problem, but I'm also going to explain my reasoning of why, because I felt a few of you were frustrated that you felt like I was forcing you to use the calculator, which I don't want you to feel that way. I want you to understand that there is a reason to why I'm doing this way, for your maximum knowledge and benefit, rather than forcing you to do something just because I said so. So the first step is to graph this on a graphing calculator, and the graphing calculator gives you a default window of minus 10 to 10, a window where the x and y axis go from minus 10 to 10. I just did minus 8 to 8 here because I was running out of room, but generally everybody in the class that I saw yesterday got some kind of graph that looked like this. I did not ask for this graph on your in-class assignment, but I will now be asking for this graph on the regular assignment, because number one, I want to know that you graphed it correctly, and number two, I want you to do the next step, which is to make a little rectangle. Actually, physically draw that rectangle on your graph and show me the region that you're interested in. We're after this point where it crosses the x-axis, so that's the region I'm interested in, and that's the window I'd like to see. So I'd like you to draw that for me and show me that that's the window that you're getting. Now when you draw this, you see that x in your rectangle starts at 0 and your x ends at 2 the way I've drawn it. I'd like to mention one more thing. I need to see these numbers, because without these numbers, none of this makes sense. So I have on the rubric right now that an unlabeled graph will cost you full points, because I really can't tell what you could or could not see without these numbers in place. So make sure that you label your axes, make sure that you look at the rubric on the side, and you've covered everything. Okay, now we have the rectangle. The next step is to figure out what your x-min and x-max have to be. Well, that's going to be 0 to 2. And that's all you need to type in. So I put in x-min and x-max as 0 to 2, and this is what I got. So now I can really see where that root is. It comes before 1. Now the y-min and y-max stayed at minus 10 to 10 for me, and it didn't make a difference. So you could keep it like that if you want. If you made it less than minus 10 to 10, if you made it, for example, minus 2 to 2, it will give you even a closer range of what you're looking at. Notice that I said the word range. This is exactly what we're skipping in the book. We're not looking at domains and ranges of functions and graphs, because you're doing that. That's what you're doing when you do this rectangle. You've now made the domain 0 to 2, and the range I kept at minus 10 to 10. If I want to get a better look, I'll make the range minus 3 to 3. I'll make the y-min and max change. And you can see in real time and understand what you're doing, because you're applying that for a particular reason. In my experience, doing that as a separate section takes a lot of time, and no one gets it anyways. They don't understand what the connection is. They're just following the rules. And that's a pretty useless thing to do. To me, if you've already gone through the aggravation of parking at MSU, paying the tuition, walking over to Richardson Hall, you may actually have to use the nasty bathrooms in Richardson Hall, and coming into our 100-degree room and sitting there. That's a lot of pain for no gain. And that's why I'm doing it this way, so that you walk out of here with a skill of being able to use your calculator and really understand what the domain and range are. So I did want to get that philosophy across and not have you think that I'm just trying to force you to do it, because I'm not into forcing people to do anything. So now, you want to use the trace button to find the root. And what I got when I did my trace button, that little cursor blinks, I saw people using it yesterday, I got x equals 0.4, which I saw most of the class was able to figure out. Now if your window's not small enough, then you might get something that's a little bit off of 0.4, and that has to do with the way the calculator samples the points that it's going to give you in the trace button. If you have your window size too big, like if you had minus 2 to 2, then you might get like minus 0.40 or 0.405. You'll get an approximate answer. So that's the benefit of making your rectangle as small as you possibly can around the region in question. So what I'm going to do on the rubric is I'm going to make sure that your rectangle here, the x min and x max from your rectangle here, match up with what you set your windows to be. And that would show me or demonstrate for me that you're making the connection and make me feel better about us entirely skipping the sections on graphing. The next step is to make sure that your calculator point works. Now I'm going to have this as a prompt in the exam so that you know that you're supposed to do this. So we're just going to plug 0.4 inside the formula that we have, and I should get 0, which when I ran it on a calculator I got 0. So it is indeed the x value, it is the root. And I didn't find any more roots. There were no more crossings. So I have the full answer from the back of the book. Now, when you do this, I gave you several problems like this. It should go faster and faster. It should take you approximately a minute to get through all of this. So it's like flipping to the back of the book and getting the answer. The first few times you do this, you're getting used to your calculator. That's going to take you some time, but it's a startup cost and you'll never have to do it again. You'll know how to do it. Now, you're going to what we call analytically verify that this indeed is the root by using synthetic division. This was the analytical way they wanted you to do the problem. So let's check it. What's the protocol? You put the root here in question that you got, that you already know is going to work from your calculator. It goes up in the little box. The coefficients of the polynomial go from left to right. And you will be using this in Calc 1, synthetic division. This is used for polynomials that have degree higher than 2. So we have the 5, 8, 6, and minus 4. It's very useful if you don't have the calculator. You can guess what one of the roots are and then start this process. So the first step in the algorithm is that the 5 just drops down. And then I take the 5 and the 0.4, multiply them, and add them to the 8. 5 times 0.4 is 2. When I add, I get 10. 10 times 0.4 is 4. Add, I get 10. 10 times 0.4 is 4. I get 0. Notice that 10 times 0.4 there, I get 0. If you did everything right, you should get a 0 here. So this is a totally checkable problem at every step of the way. So what's the equation in factored form? Well, here's how it looks. I take x minus the root, and this is the remaining portion. The coefficients come from the 5, the 10, and the 10. So that's this equation factored. This synthetic division gives you a way to factor. And one of the problems I assigned you asked for that. They asked for the actual factoring of the problem using synthetic division. So this is what you would do. And in the test, I will ask you for the factored form. I'll prompt you, and I'll make sure that it's there. It's the full answer for this problem. Now, the very last thing I'll ask you to check is to really verify that there's no more roots. We already know there's no more roots. There is only one crossing. How do we do that? Well, we take this guy here and we set it equal to 0 and solve using quadratic formula. When I do that, I get a negative under the square root. Because I have a negative under the square root, there's only what we call imaginary or complex roots. There's no more real roots. And the question asks you for real roots. So, therefore, we can conclude there's no more roots and we're done. The only root is 0.4 and the fully factored form of the polynomial is given in step 4. And that concludes everything. I hope this helps. Again, all the problems on the in-class assignment and one problem I'm going to pull from exam 1 will be on the exam. That includes the whole, you'll still get all your rules that you had to memorize. You will also get the unit circle will be there. Somebody asked about that. It will be there. The log laws and the laws of exponents will be there. Those things are going to be always there. In addition to that, you'll actually get a problem you have to get your hands dirty on from exam 1 and all the problems on this in-class assignment. Feel free to ask me any questions that you need over the weekend and I'll help out, and then I'll see you Monday. And again, I have office hours from 11 to 1 on Friday.